Today we're going to take a look at solving exponential equations. And as you see down the side, it says, can you make the bases the same? So let's take a look at this first one. What is our base? Well, our base is 4 and 4. Well, if our base has to be the same, then the exponents have to be the same. So we are solving the equation x plus 3 equals 2x plus 1, and we're just solving for x. So 3 equals x plus 1, so x would have to equal 2. And we can plug that back in here to check. Is 4 to the power of 2 plus 3 equal to 4 to the power of 2 times 2 plus 1? Well, that's 5 and 5, so it has to be the same. So the next one, they're going to get a little trickier. Our bases aren't the same. Our base is 3 to the x. Well, 27, can that be written as a power of 3 with a base of 3? So 3 to the x, 27 is 3 to the third. So in this case, x has to equal 3. When you take a look at the next one, we have a base of 2 over here. So this other side, can we rewrite it with a base of 2? So 2 to the x minus 2 on this side. 1, 4, well 4 is 2 squared. So this is looking closer, but we have a base in the numerator here and in the denominator. So we know how to switch that is by using a negative exponent. So 2 to the x minus 2, 2 to the negative 2, because we know that's really 1 over 2 squared. So now our bases are the same, so we can set our exponents equal. So x minus 2 equals negative 2, plus 2 plus 2, x equals 0. And the nice thing is you can always double check this. So if we plug in 0 over here, we'd have 2 to the 0 minus 2, so 2 to the negative 2, 1, which is 1 over 2 squared, which we have over here is 1/4. So this third one here, let's see, we have a base of 3, and this is like 3 to the first. So this one, 3 squared is 9. So when we have parentheses, we just have to multiply those exponents. So our, let's write equals 3 to the first. So our exponents have to be equal here. So we have those parentheses, so we just turn it into the multiplying those. So we have 2x minus 6 equals 1. So 2x, that would be 7. So x is 7 over 2. Or as a decimal, we could write it as equal to 3.5. So we're going to take a look at some that get a little trickier, but again, our goal is to make the base the same. Well, on this side, I notice we have 12 times 3 to the negative x minus 1. So the base of our exponent is 3. So let's see if we can get that by itself. So I'm going to multiply it by 1/12 on each side. So now we have 3 to the negative x equals 4 over 36. Well, 4 over 36 reduces down to 1/9. So can we make those bases the same? Well, 3 to the negative x, 1 over 3 squared. So again, we have that negative exponent. So we have to make this 3 to the negative 2. So we have negative x equals negative 2. So x would equal positive 2. So the next one, we got a lot going on. But what is the base of our exponent? Well, it's 6. So can we rewrite everything with a base of 36? So 6 to the negative 2x, 6 squared, 1 over, well, let's see, this is 36 to the half. So we're almost there. So 6 to the negative 2x times 6 squared, 1 over 6 squared is 36 to the half power. Well, we have several bases, so our bases are the same, so we add our exponents. So 6 to the negative 2x plus 2 equals 1 over, we multiply those, so 6 to the first, 2 times half is first. Well, let's see, 6 to the negative 2x plus 2, 6 to the negative 1. So now once again, our exponents have to be equal. So negative 2x plus 2 equals negative 1 minus 2. Negative 2x equals negative 3. So x is 3 over 2. So this next one here, can we make our bases the same? Well, our base is 2, our base is 3, so this one, it's going to be not possible, and we'll learn how to do it with a calculator, but it's not possible without a calculator. So now we're going to take a look at what do we do here when our exponent, instead of being our variable, instead of being in the exponent, it is in the base. So if we take a look at this one here, you'll notice it's x to the 2/3. Well, to get rid of that 2/3, because we're solving for x to the first, we multiply the exponent, we just raise it to the reciprocal. Because 2/3 times 3/2 is 1, so we have x to the first equals 16 to the 3/2. Well, let's see, so x equals, it's the square root of 16 cubed, so that would be 4 cubed, so x is equal to 64. So this next one too, we want to get that base by itself, so divide by 3. So we have x to the negative 3/5 equals 8. Well, we really just want x to the first, so to the negative 5/3 power. So now we have x to the first power equals 8 to the negative 5/3. Well, let's see, it's a negative exponent, so x equals 1 over 8 to the positive 5/3. So this is that cubed root of 8 to the 5th power. Well, what cube gives you 8 is 2, so 2 to the 5th, so x is equal to 32.